So, you guys will get to do this on Monday. Because what I do is I show you the process of taking a weak acid and titrating with a strong base, and then you guys actually do it, and then check your pH values along that way. Okay. So we're going to add 0.15 molarity NaOH to 10 milliliters of 0.3 molarity HC2H3O2, which is acetic acid or vinegar. So we're going to go start out at 0 milliliters. I would like everybody to find the pH of the solution before we add any of the base to the acid. Determine that. First thing I need you to do is determine what the pH is of the solution before you add anything to it. Okay? So you set up your expression that says 1.8 times 10 to the minus fifth is the constant equals, and then we have our equation down here that would be HC2H3O2, that would be H plus C2H3. So those two there, you have your initial, and that would be, we have a 0.3 molarity, and this would be 0, 0, and then it would be, I'm going to skip the change because we already do that, so I'm going to go straight to E. I'm pretty daring, aren't I? Okay? I don't know if I can do this. 0.3 molarity minus X. Then we have X and X. So then, as always, X squared over 0.3 molarity. We can take out the minus X. That equals 1.8 times 10 to the minus fifth. We're going to multiply by 0.3 and take the square root of it. That gets us our X value. Okay, so X is equal to what?
0.0023.
0.0023?
Yeah.
That's what I got. You take a negative
0.0023. Then you go ahead and take the minus log of 0.0023. And that's your pH. And your pH to begin with is 2.63. Any questions on that? So that's something that we've done. Questions?
Static.
Okay. So
It's been too long since it's been on the menu.
So 0 milliliters. The pH is 2.63. Any questions with that? So we put the probe in, boom, 2.63. That's the pH. We're going to start adding. To our concentration, which is 0.30 molarity. We're up here, we're at 0. And what we're going to do is we're going to add 5 milliliters. So we're going to drain out 5 milliliters. So this is kind of what we went through yesterday. So if you kind of missed yesterday, this is what...
And why are you doing 5?
We're just going to pour out 5 and see how it affects the pH. Okay? So we have this equation. It says C2H3O2 and original equation. Okay. And I'm going to make multiple copies of this so I don't have to keep going on. I don't know why it's so high. Normally not that high. So I'm going to have to do it on. Give me a second. I don't want to keep on writing that over and over again.
Understandable. Another pencil come off for a second.
Where do I make a copy? Used to be up here.
Right one or both?
Here?
Right one?
No.
And you want that list?
Probably highlight it.
Yeah, I used to have some more options up above. I got a new computer because my hard drive busted, and so I guess I'm going to just have to rewrite it. It's not that big a deal.
I wish you'd cry.
Okay. So we have initial before and initial after. This is kind of something that will make more sense when we go through a couple of these, okay? So our initial before was point. Now, we're going to put it in moles from now on until it's to the equivalent point. So everything now I'm going to put down on this initial before and after is going to be just in moles. I'm not going to deal with molarity because it's not going to affect my calculation. Okay? So what I'm going to do is I'm going to calculate the moles before. So I had 10 milliliters. I have 0.30 moles, or molarity. How many moles did I have of HC2H3O2 before?
0.03.
Okay, so 0.0.
No, it's 3. Because you take 3. Oh wait, never mind.
That's-
You're right. 'Cause
yeah.
it's
Is it 0.003?
0, 0, 1,
Right?
0, 3.
Because you take 0.01 times 0.3.
Yeah.
No, it's point. Is it just 0.0?
Well, whatever you do, when you take 0.01 times 0.3, that's your number. So I believe it's 0.003.
It is.
Okay?
Yeah, it is.
All right. So these were 0. So what we're going to do is how much do we add, how many moles did we add of OH, or NaOH? So how much did we add of NaOH? 0.005 times 0.15. How much is that? So 0.005 times
7.5 times 10
molarity liters, that gives you moles of NaOH. So how much?
0.00075.
0.00.
times 10 minus 4.
Okay, so I'm going to go 0.000175, right?
75. Just 75.
Just 75?
Yep.
Okay. Now, what they do, if this is, you can do it, and we can maybe do it on the next one. They will put it in millimoles. So instead of having all those zeros all the time and something in scientific notation, they'll say that this is 3 millimoles. And then they'll say this is 0.75 millimoles.
Millimoles.
Okay? It's up to you. I'm used to doing it this way without the millimoles. Okay? Now, this is what's going to happen. It's going to take away, the OHs are going to come in and take away these H's. How many? Well, the same amount of moles that you have here is going to be taken away. So 0.0075 moles is taken away from this. So then after we put it in, these go away. We're left with 0.00, is it 225? Is that right?
Yep.
So Now, if it takes the H's away, it leaves behind the C2H3O2. Guess what? Initial, after you add it, okay, this is still going to be, this is what we're going to call X, because we'll be able to solve for that. Okay? How much are we going to have of this? 0.00075.
Wait, why?
Why? Because when the H's go, how many of these do you have?
The same amount?
Same amount of the H's that came off.
Came out.
So the OH's that are added, take away the H's here to make water. We're left with C2H3O2. How much are we left with?
Oh, okay.
0.00075. Now this is what we did yesterday. We had to find a pH of, this is kind of like a buffered solution now. It's creating a buffered solution. So the solution's pH doesn't change a whole lot until you get to the end point. Okay, you can kind of see that on a graph that we'll do next week. So we have, this is really easy. So we have 1.8 times 10 to the minus fifth is going to equal the, what we have here, 0.00225. Now I'm going to leave it in moles. You don't have to find molarity. We won't do that until later. So I'm going to leave it in moles. It's okay because the volume, throughout the experiment, the volume is going to be constant. All right, the volume does. This is the same volume. This is the same volume. That they're all the same volume. So we can deal with moles. Then that's going to be. You're going to have the 0.00075 moles up here, which is the C2H3O2 times X. Solve for X. Okay, so and then after this one, I'll show you an easier way. It's an equation that is on your sheet. They used it yesterday to solve for the pH, so you don't have to always.
So that 0.0075, is that representing the OHs or the which? That, okay.
Okay. So what's the concentrate? What is X?
5.4 times 10 to the negative fifth.
5.4 times 10 to the minus fifth. Okay, you log that number, and that gives you the pH. So you take minus log of that number, because that's X, and that gives you the pH. So the pH is equal to what?
4.27.
4 point what?
27.
4.27. Okay, our pH is going up. Is that sound right? Okay, we add 5 milliliters of a base to it. Then the pH has to go up because it's getting more toward that basic side. So it's 4.27. Questions? We won't on this next one. We will not use the new method because what we're going to do is we're going to get to the point where it's halfway titrated. And if it's halfway titrated, it's really easy. Okay? So, questions you have on that? Because I'm going to do some erasing. Questions? All right. Okay, so we can make trusty calculator out here and figure out something so I don't mess up on the halfway titration point. Okay. So now what we're going to do is we're going to add 10 milliliters. So now we're going to add 10 milliliters. We're down to here. Okay, so how much of the base we added will be what you subtract. So how many moles did we add of the base?
Another 0.0015.
0.0015.
Yeah.
How much is left over? 0.0015, right?
Yep.
So half of it's titrated. Over here, it's going to be 0.0015, correct? That's in moles. Here's our X. If it's halfway titration, it's really easy. Okay? Because all you do is the Ka is going to equal, which is 1.8 times 10 to the minus fifth, is going to equal your H plus, okay, this is going to be 0.0015, and then this down here is going to be 0.0015. So we can, those cancel out, right? So go ahead and solve for the pH. So if you ever want, if you know it's a halfway titration point, all you have to do is take the minus log of the Ka and you got your answer. Does that make sense? Because all you have to do, if you know, hey, I got half of each. I've got equal amounts of the anion and the acid. All I have to do is take the negative log of the Ka. So what is that going to be? So after 10 milliliters is added, what's it going to be?
4.74.
4.74. Good. That's right. That sounds right to me. Questions up to this point. So everything we do, we have kind of an initial. We have an initial after we add the acid, and that kind of keeps track of how many moles are being produced throughout the setup. Okay. I'm going to have you do this on your own. I'm just going to ask for an answer. Hopefully you guys get it all right, so I don't have to go through and explain it. So this is what I want you to do. I want you to add 15 milliliters. I want to know the pH after 15 milliliters have been added. Tell me what the pH is after 15 milliliters of the acid is added. So I'm going to erase some things here. You go through and see if you understand it, the process. Okay? And then I'll bring in the equation later on. So now we're adding 15.
How do you know that your C2H3O2 is going to be the same as your?
Oh, how do you know when these two are equal?
Yeah, how do you know that's true?
It'd be half the number of moles that would be needed.
Oh, there.
It would be